Okay, we're going to go into lesson 48. Lesson 48, we're skipping 47 because we did that for the last quiz. That was the starting to move sinusoids left, right, up, down, stretching, shrinking, and all of that. So writing those equations. So, what are we doing today? We're doing powers of trig functions. Powers of trig functions. Now, before we even get started with this, if I asked you, what's the sine of 120, you guys should be able to handle that. You guys should be able to tell me what sine of 120 is. Let's go over it. So, sine of 120, the first thing you possibly would have done was to go to create a graph. And graph 120 degrees over here somewhere, yeah? Yes. And at that point, you kind of ask yourself, what's the leftovers, because that's my reference angle. It's 60. And so you're like, oh, wait a minute. That actually forms a 30, 60, 90 triangle right there. And that'd be 1, 2, square root 3. Now that would be a negative 1 because I'm going backwards, yeah? And so you just ask, what's the sine of that? And you would say, oh, that equals opposite over at the hypotenuse, which is square root of 3 over 2. We know it's positive because it's in the second quadrant. It's a y value. It's above, right? Mm-hmm. Not that big of a deal. Now, that's not what we're doing today. Today, we're going to take that same exact thing, but we're going to add a little twist to it. Now, I'm asking you this. Sine squared of 120.
Does that just mean square root of 3 over 2 squared?
It does mean square root of 3 over 2 squared.
3 over 4.
Now, why does it mean that? Well, it means that because they write the 2 on the sign, the squared on the sign, and not at the end, because this can get a little confusing sometimes. Because that's what that really means. It just means the function evaluated at that angle squared. It's confusing because sometimes students leave off the parentheses. And then it looks like sine of 120 squared. And that's not what we're going for here. So like Devroy said, all I'm doing is then using substitution. I'm taking the sine of 120, which we just did above, and substituting that in. So it's square root of 3 over 2 squared. And how do you take a power of a fraction? Power of a quotient. It applies to the top and bottom. So therefore, all we are doing is square root of 3 squared over 2 squared, which then equals 3 over 4. Not so bad. Now the thing about this is they're not just going to give you one. They're going to give you several to put together. Am I good to change page? I was about to say channel. I was going to say channel. I watch too much TV, I think. So, what they're going to do to us instead is they're going to put stuff together. Sine cubed of negative 60 plus cotangent squared of 330. Now, the book is going to use degrees in there. It's probably a good habit to write degrees when we're talking about degrees. I'm also going to do radians. Radians, they're not going to throw problems at you in this book. In this lesson in radians, the next lesson when we get to 49, they're going to give you radians, and they're just going to expect you to know it. So I'm going to go over it today on our next problem. But we just have to evaluate this. Now, there's a couple ways to attempt this. What we're trying to do is you find coterminal angles. You say, hey, you kind of graph the angle. Is it positive? Is it negative in that quadrant? You also deal with cotangent, which is 1 over tangent. So you got to take reciprocal functions sometimes. So you got to do a lot of different things sometimes to make these work. But again, it all goes back to what you've already done before. Just don't forget, now we can take exponents. Now here's the thing. If I take an even power, like a square, a fourth, or a sixth of something that's negative, it turns it positive. If I take something that's negative to an odd power, 1, 3, 5, 7, 9, it stays negative, or it becomes negative still. Okay, so you got to be careful with that. So, taking a look at these, what I want to do is I'm going to change the sign of negative 60. Maybe I'm going to change that to sine of negative 60 to the third power. I don't know. I'm just going to try getting that power out of there for now so I can evaluate the inside part. Cotangent. I don't like cotangent. I'm going to turn that into 1 over tangent. So it's plus 1 over the tangent of 330. And I'm going to put square on the outside of that. Notice that it's on the bottom. It's not the whole fraction. It's just on the tangent of 330. And now I can start to evaluate some of these. Oh, sine of negative 60. Well, maybe I'll just graph it. Where's negative 60? Which quadrant? Fourth quadrant. And it leaves me with a reference of 60. If I go down 60 degrees, it's a 60-degree angle with the x-axis. Oh, wait a minute. That also would be my 30, 60, 90 triangle, where 1's opposite the 30, 2 is my hypotenuse, and square root of 3 is my other leg. It would be a negative square root of 3. That's a good observation. We should know that because we are going down. That helps us identify the sign of sine. Because now, if I ask you what's the sine of 60 here, you would automatically say that it's negative square root of 3 over 2, and then we are going to take that to the third power. Now, if I didn't put that negative in front of that square root of 3, then I would have came out with a positive square root of 3 over 2, but then a light bulb hopefully goes off in my head, and I say, hey, I'm in the fourth quadrant, I'm dealing with sine, I know down there sine is negative, you put a negative in front. There's a couple different checks that we're going through that you guys already know that we have to take in precautions here. Now, tangent of 330. So let's graph 330 degrees. 330 degrees pushes me into fourth quadrant, so I'm here. It leaves me with a reference or a leftover of
60.
90.
30.
30. Because how far is it to go all the way? 360. So if 330 are on the outside, there's 30 on the inside. Hey, that is very nice because that's my 30, 60, 90 triangle. Again, 1, 2, square root 3. We'll make that a negative 1. How do I do tangent again? It's opposite over adjacent.
Which you can just basically do adjacent over.
So if that's opposite over adjacent, that'd be negative 1 over
You can switch right away.
square root of 3. And all of that here is squared. So I know I cannot just change it right away.
You could then square it later.
No.
Always.
It ends up working this time, but it might not always work that way.
So when you say change it, you don't go to square root.
Don't flip it. He wants to go right away to square root of 3 over 1.
I'm not going to square root of 3. Change it.
Okay, you're saying multiply top and bottom by square root of 3? Because I don't like square roots in the bottom. Right. But here's the thing. You could do that first. You could do it first before you square it. But I also know that I'm doing things to this. Like I'm going to take the reciprocal. I'm going to square it. So I will not do that until I'm very last and I go, oh, I can't do anything else. Now I'm going to rationalize it. Because if you do that and all of a sudden you realize that you're going to flip it, well, all of a sudden the square root's back on the bottom and then you have to do it again. So don't do more work than you have to.
Do cotangent, the secant, and the other one?
Cosecant, secant.
Yeah, sure.
Yeah?
Do they all have the same negative areas as the regular one?
Yes. Yes. Because they're just the reciprocals. So it'd be made up of a negative or a positive sine, cosine, and tangent.
Is there a reason you switched the numbers on that triangle?
The reasons they're switched is because we're talking about different angles. Over on the first one, here, it's 60 degrees.
Yeah.
But over here,
It's 30.
it's 30. So the triangle was rotated or flipped differently. So you have different angles. And it's that way all the way around the unit circle for us. It only uses two different triangles, 30, 60, 90, or 45, 45, 90. Those are the only multiples of angles that we have. Okay, so we're almost done. I got to take that thing to the third power. So wouldn't that mean that it's still going to be negative? So it's a negative. But what does it mean to be the third power, though? Well, first of all, could I say that this is square root of 3 cubed over 2 cubed? Okay. We'll just take it one step at a time. Plus, I'm going to square it, so it's 1 over 1, negative 1 squared over square root of 3 squared. Because I'm just squaring a fraction. I'm running out of room. So now we can clean this up. What does it mean to be square root of 3 cubed?
3 times square root of 3.
Square root of 3 times square root of 3 times square root of 3. So if I'm going to write it off to the side over here. Square root of 3 times square root of 3 times square root of 3. 2 square root of 3's would make a?
3.
So it's 3 square root of 3.
Negative.
So over here, and the negative's there, right? So it's a negative 3 square root 3 all over 8 plus 1 over 1, because negative 1 squared is 1, all over 3. Ooh, when I divide by a fraction, I will flip in. So that 1 over 1/3 is 3. So it's negative 3 square root 3 all over 8 plus 3. We probably should get a common denominator. So let's change the color here. 3 and 3. Oh, not 3 and 3. It's 8 and 8. So 3 times 8 is 24. So this would be negative 3 square root 3 plus 24 all over 8. And that's what I'll be looking for. Yeah, it's kind of squishing the bottom. Sorry about that. The little words are not on my screen. They're up there, though. Negative 3 square root 3 plus 24 all over 8. Next one. Cosecant squared of negative 9 pi over 4 minus tangent squared of pi over 4. So, we got to get used to radians and degrees. And so, I'm going to give you some of these now. We treat it just like any other time when we were evaluating when it was radians. We should know pi over 6 is how many degrees? 30. Pi over 4? 45. Pi over 3? 60. Pi over 2? Pi? 180. And 2 pi? 360. So you should know those inside and out. So therefore, when we start to make our 30, 60, 90 triangle, it's pi over 6, pi over 3, pi over 2 triangle. No big deal. Okay, our numbers can come that easily then. So, when I see problems like this, I see a cosecant, which is the reciprocal function of sine. So we can got a couple options here. I can say, hey, this is the 1 over the sine squared of negative 9 pi over 4. Minus tangent of pi over 4 squared, maybe? We'll take it that way. Ooh, we should probably build some triangles then, because I can actually evaluate that second one. The second one is a pi over 4. Pi over 4 is what again? 45. So I'm going to use my 45, 45 triangle. Oh, sorry. I'm going to back that. I'm going to say pi over 4 and pi over 4. So the sides are 1, 1, square root of 2. What's the tangent of pi over 4? Opposite over hypotenuse, so it's 1 over 1. So it has to be 1. So that's pretty easy. So it's minus 1 squared. Yay, we got half of it done already. The other one's going to take a little bit more thinking. So let's think of this one. I can change it though. I could say this is sine of negative 9 pi over 4 squared. Okay. Now, what does it mean to go pi over 4 again? How many times? How many are there in pi? There are 4 of them in pi. There's one here, here, here. That'd be 4 of them. And here, here. That's 4. So 8 total, yes?
Yeah.
How do I figure out where I'm at? How many of them am I going? 9. Which way? Down. So, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I am down here. How many steps away from there am I? 1. 1 step down. Right? Or, if I wanted to go the other way to get a positive angle, it'd be 1, 2, 3, 4, 5, 6, 7. So there's options. But either way, I know that this is going to be a pi over 4 angle, yes? You guys all see that? Okay. That means that sine of negative 9 pi over 4 is the same thing as sine of pi over 4. Yes?
Yes.
But it's in the 4th quadrant, so sine has to be
Negative.
negative. So I put a big negative sign on the front. Because I'm down here, the reference angle, remember reference angles only reference into 1st quadrant, so they're always positive. We just say it's negative because we know sine is down below, so that's negative. What's the sine of pi over 4? Oh, let's go back to our triangle. Opposite over hypotenuse. So, sine of pi over 4? 45. No. It's 1 over square root of 2. So 1 over square root of 2 squared minus the 1.
There's a negative in front of you.
Oh, we did not square that yet, so it's negative. Whoops. It's negative. But when it's square negative, it becomes positive. So we get 1 over 2 minus 1. Wait, 1 divided by 1/2?
2.
Equals 2. And 2 minus 1 is 1.
So stupid.
Okay, next one. Perpendicular bisectors. Perpendicular bisectors, guys. We've already done something that could actually solve this. The question that we're going to deal with here is the fact that I'm going to give you 2 points. Like 4, 2, and 8, negative 3. And I want you to draw the line that is a perpendicular bisector to this. Or the line that is equal distance between these points. Equidistant, yeah. The one where we did this, graphed the 2 points, and we found the line through here. Because we said, oh, that's x, y, and we drew the distance. We set the distances equal to each other and solved for it. Right? We did that about 5, 6, 7, 8 lessons ago. I'm not sure. Here's another way to do this. The way that you guys probably more likely like. The biggest thing that you have to deal with is perpendicular lines have opposite reciprocal slopes, yeah? Perpendicular lines have opposite reciprocal slopes. You should know that. Parallel lines have the same slope. Perpendicular lines have opposite reciprocals. Okay? If it's going to bisect it, it means it's going to cut it in half. You need the point in the middle. And so we use the midpoint formula. So use the midpoint formula. And then, the very last step you use is y minus y1 equals m times x minus x1. Once you got the new slope, you got the midpoint, that's the point in the slope you plug into the formula. Okay, I'm going to go to a new page, give myself more room. So here we go, 4, 2, and 8, negative 3. So we have two options. You can start with finding the slope or the midpoint. Which one you want? Slope. Okay, slope formula is m equals. There's two ways to do this. You could graph it. You could graph it, make a triangle. Yes, rise over run. Or you could use a slope formula, which was y2 minus y1.
It doesn't matter which point you use for y2 or y1.
Correct.
But they need to do the same.
As long as you keep it consistent, x1 and y1, you're fine. So, let's just go in order. 1 and 2, yeah? So, it'd be negative 3 minus 2 over
8 minus 4.
8 minus 4, which is
Negative 5 over 4.
negative 5 over 4. That's the old slope. This is old. So, what's the new?
4/5.
It'd be 4/5 because I want the opposite, so opposite sign, and reciprocal. Now I need to find the midpoint. What's the midpoint formula? It's like the average, guys. x1 plus x2 all over 2. y1 plus all over 2. Midpoint. Average the x's, average the y's. No, that's the equation. That's the equation you got to use. So once after you find the midpoint,
So 6 and negative 1/2.
so we have to do 4 plus 8 over 2 and 2 plus negative 3 over 2, which is 6 comma 1/2. I may have to switch to another page here, but we take the slope. That was bad. Yes, it's a negative 1/2. Thank you, Noah. And the point, 6 negative 1/2. M equals 4/5. X, and the midpoint was 6 negative 1/2. Now we need to form the line equation. I'll go back later. And so I'm going to put it into y minus y1 equals m times x minus x1. So it's y plus 1/2. Why is it plus 1/2?
That's my negative.
You're subtracting a negative. And 4/5 times x minus 6.
Which is going to be 24.
Distribute. So y plus 1/2 equals 4/5 x
Plus 24.
minus 24/5. Then the only thing left to do is
But we gotta
subtract.
get common denominators.
Get common denominators. Oh no. Common denominator between a 5 and a 2 is a 10. So I go to do 2, 2, 5, 5. Yeah? So this would be a negative 48 over 10. And this would be a negative 5 over 10. If I was to put those two together, what do you get?
43 over. No,
Why not?
52
It's
over.
definitely
53
52.
over.
53.
It's a minus 53 over 10. That, ladies and gentlemen, is the equation we were after.
You feel more accomplished? Yeah.
Homework is page 335, 1 through 2, 9 through 13, 16 through 17. Please keep up on homework. I know this is the last push. We got 1 quarter left. Do not think that this is a good idea to wait till the day before a quiz to start doing this homework and finishing it.